All right, this is section 6.2, part 2. Let's keep on looking at this problem right here. We already found a key point to be 0, 73. Let's also look at the key point from the parent function 0, 1. Okay, so this is from the parent function. Now what happened was we scooted down 8 units, so I'm going to subtract 8 from the y value. So that'll be 0, -7. And then we move to the right by 4 units, so I'm going to add 4. So 4, -7 would be another key point that we have. Okay, now let's look at B. B is between 0 and 1, because B is 1/3, so we have a decreasing function. Okay, let's look at the domain. We'll go ahead and look at the domain, which we already know is from -infinity to +infinity. That doesn't change. The range is going to be from -8 to infinity. And let's look at the horizontal asymptote. That should be y is equal to -8. So let's come down to -8. We'll draw our horizontal asymptote. Go ahead and plot those 2 points. Now, this one right here, 0, 73, I only went up to 10, so that one doesn't help us too much. Let's plot the other one. So 4, -7. So 4, -7, about here. Okay, so we know it's way up here. We have the point 0, 73. We know that this is a decreasing function. So it'll look something like this right here. Getting closer and closer to that asymptote. Okay, so let's look at it here. This is what it looks like. Okay, so notice we've got the horizontal asymptote at -8, and we also have the point, here's 4, here's -7 right there, and it's also a decreasing function. And also our range goes from -8 to infinity, and our domain goes from -infinity to +infinity. Okay, let's look at this one. 1/5 raised to x plus 2 plus 4. Okay, our b is 1/5. Our c is 2, and our d is 4. So 0, 1/5 raised to 2 plus 4. So that is 1/25 plus, we'll put that 4/1. We multiply it times 25/25 to get the denominators the same. So we've got 1/25 plus 100/25. So we get 0, 101/25. Okay, so I grabbed my calculator, and that's about 4.04, the 101/25. So we'll put that over here, one of our key points, and then we'll look at the parent function key point and see how that changed. So 0, 1, this is the parent function. Okay, we went up 4 units, so 0, 5, and then we went to the left by 2 units, so -2, so -2, 5. Okay, so there's our 2 points right there. And then we've got a b that is 1/5, so b is between 0 and 1, so we have another decreasing function. Our domain goes from -infinity to +infinity. Our range goes from 4 to +infinity, and our horizontal asymptote is y is equal to 4. Okay, so right here, y is equal to 4. We'll plot our 2 points, 0, 4.4. So that would be about, we'll say it's just a hair above this right here. And then -2, 5 right here. Okay, now it's a decreasing function. So it should be coming from this direction right here and getting closer and closer and closer to this asymptote. Okay, now this is what it should look like, is this right here. Notice there's our horizontal asymptote, y is equal to 4. Now we have an a y-intercept just a hair above that 4, so that's probably 4.04. And then we have a negative 2, 5. There's our point right there, so that's what we got as well. And notice it is a decreasing function. Okay, now let's look at stretches and compressions of the parent function f of x equals b raised to x. Okay, so for any factor a greater than 0, and we'll talk about if it's less than 0, then that means that it's a negative number, and that's getting into reflection. So we don't want to talk about reflection right now. We just want to talk about stretches and compression. So we're going to keep a greater than 0, which is basically saying a's got to be a positive number. The function f of x is equal to a times b raised to x. So if the absolute value is talking about taking that negative away, because negative is talking about reflection. So the number a, regardless of the sign, if it is greater than 1, you've got a vertical stretch. If it is less than 1, then you have vertical compression. Now this one has a y-intercept of 0, a. It has a horizontal asymptote at y equals 0, in a range of 0 to infinity and a domain of all real numbers. So let's look at vertical stretch and compression. Let's look at their graphs. Okay, so we have this function right here. That is 2 raised to x. And then we have this function right here. That is 3 times 2 raised to x. So notice how the a is bigger than 1, so we have vertical stretch. So it's like you picked this function up and you picked it up towards the positive y values going up to infinity, and so it stretched it, so we're going up faster for the y values. Now over here is 2 raised to x, and then you have 1/3 times 2 raised to x right here, the second function. Okay, so notice how the y values, it's on the opposite side of what we just had, 2 raised to x. So it'll be going up, looks like a little bit slower for the y values. And when I mean a little bit slower, if we look at x is equal to 1 right here, for the original function 2 raised to x, it's already at round 2 for the y. But for 1/3 times 2 raised to x, it's at 1. So it's going a little bit slower for the y values. Now if we came back over here, we'll look at 1 for this one as well. And so for the original function, it's at, we said, here's the original function right here, it's around 2. But for 3 times 2 raised to x, it's at 5. So it's going up the y values quicker for the vertical stretch, but slower for the vertical compression. Okay, so let's try to graph this one right here. 4 times 1/2 raised to x, and we'll say the domain, the range, and the asymptote. So we have a key point, and that is at this right here, 0, a. So our a is 4, our b is 1/2. Okay, so we have a key point, and I'll write it over here, 0, 4. Also notice that it hasn't been shifted up or down. We don't have a plus or minus some number, say 3. We don't have that. So our horizontal asymptote is still y equals 0, which is the x-axis. So we'll get that in there. Okay, 0, 4, so right here. Since b is 1/2, and that is between 0 and 1, we've got a decreasing function. Okay, now we took the parent. If we take the parent function, This 4 is affecting the y values, so we would take this 1 and multiply it times 4, but essentially we would get 0, 4 again, which they've already given us. Okay, so what you could do is you could have a table of values just to get maybe a couple more points. So say we got x and y. So I'll do a couple more points. And let's see, let's choose our x values. We'll do, say, negative. We'll do a negative 2 and a positive 2. Do a negative 2 and a positive 2. So I need to plug those in. So 4 1/2 raised to a negative 2. That is 4 times 2 raised to 2. So 4 times 4, or 16. Okay, so that's off the chart just a little bit. So let's go to a negative 1. Try that one instead. So that'll be negative 1. Get rid of that. So that'll be a 2. Okay, so that'll be 8. Okay, so we got a negative 1, 8 right here. And then we'll do positive 1. No, we'll go ahead and do 2. Okay, so then this will be raised to 2. So it'll be 2 times 1 over 4. Hey, that'll be 1. So 2, 1. So right here. Okay, now we've got a couple more points. So it's coming through here. Hit that point, hit that point, hit that point, and then we have a horizontal asymptote at y equals 0. So it should look something like this right here, and here's our graph. Okay, so here's our 0, 4. Here's our negative 1, 8 that we found, and then we used 2. Yeah, we used 2 and we got 1. So 2, 1. The horizontal asymptote is y equals 0. Okay, so it looks like what we just graphed. And we have a decreasing function. Now let's look at this one right here. So here our a is 1/2 and our b is 4. So we know we have a point at 0, 1/2. Oh, by the way, we'll go back over here and we need to state the domain, which doesn't change, negative infinity to positive infinity. The range goes from 0 to positive infinity, and the horizontal asymptote is y is equal to 0. Okay, now we'll come back over here. Okay, so we have a point 0, 1/2. We know that this is going to be an increasing function since b is greater than 1 here. And we also have a horizontal asymptote at y equals 0 because we didn't shift up or down in this function. Okay, so at the x-axis we have another asymptote. And this is going to be an increasing function. We'll go ahead and plot that point 0, 1/2, so that's about here. Okay, and we're going to pick a couple more points. So let's say we'll just choose, let's see, we'll choose negative, we'll do negative 2 and 2. We'll try those again. So 1/2, 4 raised to negative 2. So that's going to be 1/2, 1/4 raised to 2. 1/2 over 1/16. So that's going to be 1 over 32, which that is 1 divided by 32. That's pretty small, so let's not use negative 2. The negative 2's are not working very well. Let's use negative 1 again. Okay, so we'll get rid of these. And these might be too small as well. We might have to get a couple points on the other side. Okay, so this will be 1/2, 1 over 4. That will be 1 over 8. So essentially 1 over 8, 1 divided by 8. That's about 1.125. Those are a little bit small, but let's look at 2.